All right, so we're gonna start solving equations. So I'll do a couple, have you guys try a couple, and we'll kind of check in. So the way I would approach A is I divide by 20 first, right? So you should have 3 raised to 2x plus 1 power equals 27. I know it's 27 because 54 divided by 2 is 27, and the zeros will cancel. So when I do 540 over 20, again, the zeros cancel, 54 over 2 is 27. 27 happens to be a power of 3, right? It's 3 cubed. And the other side is a power of 3 as well. If both sides have powers of the same base, then the exponents must be the same too, right? We can conclude that. You don't have to do logs. If you solve for x, what do you get? 1. Good. Okay. So let's repeat this process for part B. I'll have you guys do C and D afterwards. For part B, it's divide by 72. You should get this, right? 9 over 72 is 1/8, by the way. Now, is 8 a power 2? Yep, it's 2 cubed, right? Or you could rewrite it like this, 1/2 cubed. And if we think about it, x over 5 must equal 3. What does x equal? Boom, got it. You can if you want, but I think sometimes it's more efficient to not if you can help it, because I just don't need to. But yes, you could take log of both sides. Yeah, then you could isolate the exponents x using the power property. X over 5 times log half equals 3 times log half. Log halves cancel. It's just an extra step, but you could do that. Or if you want to evaluate log half in the calculator, but not necessary, right? All right. Why don't you guys try C and D? Now here you're going to change bases on both sides to get them line up, and both will have powers of 2. Crap. All right, you guys get 9 halves and negative 7 halves? Do we agree or disagree? Yes. All right, Clay agrees, so we're good. All right, let's move on. Okay. Everyone else agrees. Good. Well, I don't either. But it says exact form, so you don't have to use a calculator. So let me show you how I do A. Divide by 5. Now you could take the log of both sides. Actually, do you guys like that? You want to take a log of both sides?
What else could you do?
Or just rewrite it like this.
Yeah, natural log would be way easier.
Well, that's what I meant. Sorry, let me clarify.
Oh,
Do you guys prefer I take natural log of both sides or rewrite as a log equation? Okay, we'll take natural log of both sides. Okay, well, I heard rewrite. Okay, we're gonna rewrite. So x equals natural log of 4 over 0.35. And that's an exact answer, so I'd leave it like that. That's what x equals. And then you can write natural log is fine. I'm just showing what's happening. Like the rewrite of the, or yeah, to rewrite from exponential form to log form. Next up, you have 5 to the x minus 1 equals 7/4. So x minus 1 equals log base 5 of 7/4. And then add 1 to that junk, and all is good. So do likewise for both C and D. I kind of showed you a problem like C, right? You guys remember I showed you something kind of like C as a hint?
Like A squared.
Yeah, let A or any letter you want equal 3 to the x. Therefore, you can have A squared minus 2A equals 35. Treat that like a quadratic. And for D, I'll just do it, see what happens. So you may want to cross multiply for D as your first step. Yeah, that'd be extraneous. There's an extraneous answer for part C. There's an extraneous answer. Okay. So far for part C,
No, I just thought that was funny.
let A equal 3 to the x, you get A squared minus 2 minus 35, factor it. It's very easy.
I don't even know, bro. Okay, yeah.
0. So A equals 7 or -5. However, we bring 3 to the x back into the fold. 3x can equal 7. Great. Log base 3 7 is x. 3x cannot equal -5. So I can't multiply 3 a bunch of times to make it -5. It's impossible. I can't multiply a positive number over and over again, make it negative. Just can't do it. So no good. Okay, I'll do part D. I'll leave this up while you guys do part D.
Okay, I don't know about that one.
For D, that's for D.
I haven't done D yet.
Log in parentheses 20 above minus 1.
And 6 5/3.
What?
I know. I looked at it like,
I don't think that's right.
Yeah, so one over log base 0.7.
Evaluate yours, I'll evaluate mine. I bet it's the same thing. Or I'll evaluate mine, I'll plug it in, and we'll see what connects.
0.7 from 1.6.
We just do it different ways, though. We're different people.
Yeah, yeah.
I got 5.02. 5.02.
Would you?
And you got yours? So I multiplied by the bottom, I divided by 12. I subtracted 1, got the whole thing by 4. The log of both.
Okay, here we go for part D, guys. Quiet down. But divide by 12.
yeah, I feel like.
So I multiply both sides by the denominator. I think I did it right. Tell me if I did it wrong. 5/3, subtract 1, 2/3. And then at that, divide by 4 is 1/6. And then do log base 0.7 of 1/6. Is that okay?
Yeah.
So it's gonna
Sure,
turn.
we were writing a fraction.
Okay, so that's an exact answer. All right, let's keep moving. You guys doing great. Rolling along here. Got some tri-tip soon, pull pork. All right, okay. So let me do parts A and B. Now we guys do D and C. Actually, I'll do I'll do A and D. How do you guys do B and C? I'll do A and D. I'll do A, yeah, top left, lower right. So this one should be pretty simple. Move the 1 over first. rewrite as an exponential equation. Well, it's not truly an exponential, but you know what I mean. Do a rewrite. X will equal 77? No, 78, 76? No. Yeah, 76. I think I'm right. Because 3 of 4 is 81, right? Yeah, minus 5, 76. Yeah, okay. For D, you have to use a quotient property. You'll do it on your own. And again, we'll go with exact answers. Now, ln's log base C.
So when they're, I can't really show refresh, so when they're in the same parentheses, like natural log of X plus 1,
Mhm.
that doesn't mean they're multiplied, that just means they're actually added.
Right. ln's base C. Ugh, there's a lot going on here. I don't know, because I'm running out of space.
76.
Hold on, let's just do this.
Did we skip B and C?
You guys can do it on your own. I'm gonna do part D up here. Yes, go, Angela. Yeah,
I'm sorry.
right. I mean, if I say so. Or otherwise, I'll have to give a calculator. Okay, my apologies for the messiness here.
No.
I feel like you need to well, no, you see guys usually
What's the problem?
I've already like 3 or 4 times today used a polynomial root finder. I feel like I'm not doing this right.
Like 3 wars at the same
Cool. We good?
Not like farm, like.
Yeah.
I got E squared minus 1.
What did I make? 6?
I probably made a mistake.
Yeah, you probably did.
Okay. Oh, no, I made a mistake.
I need negative. Yeah, I any other time. I did negative.
Well, make the mistake, like this isn't.
Yeah.
that-
Oh, same thing. Same thing, yeah.
Oh, I should.
Yeah.
Right,
If some of you guys got this as your answer, some of you got negative E squared over E squared minus 1. It's the same thing, guys. If you just reverse the order, it's still the same thing.
You do 40.
Was it sorry? Let me work out B and C.
Oh, sorry, I thought you finished. seeing.
Okay. Okay. We'll work out B and C.
Oh, I was looking for.
B's easy. That's just some equal to each other, right? You get 2. Yeah, that's easy. Oh, yeah.
Oh, B, right.
No, because I ran out of space. So I started B.
Oh.
Yeah.
You need to get.
I know, dude. Like you were supposed to get it for my birthday. You never did that.
Your birthday.
Like back in November.
He did tell us.
I did tell you.
He did tell us.
Yeah. See, thank you, William.
Yeah, I remember, and then no one started to go on me.
So I'll give you an honors card for remember my birthday. Okay.
Yeah, why don't we start a GoFundMe?
It's like 30 bucks.
20 bucks.
Honestly, it's just laziness on my end. I just have to just do it.
I feel like you might.
Oh, actually, I think I have one.
No, I was really good at the stylus when it was working. But yeah, but the problem is that the stylus is hard to find. Like it can't really find on Amazon. You have to go on eBay.
Oh, that stuff's sketchy.
Yeah, I know.
And what
And I asked our IT group, and it's like that's what they told me to do, and I get reimbursed.
Oh, you get reimbursed. We had this conversation.
See, you remember? Okay, good. You remember? Good. And I think one of them is extraneous.
Yeah.
All right, here we go. Here's part C. Only two works, not
Not
half. So use a product property and power property that equal to each other. You get a quadratic.
Yeah, I'm coming.
That is a factorial quadratic. You get half or two, but you can't log negative numbers. You gotta be mindful about that. So half is no good. 2 is okay. We stick with it. Because then you get natural log of 1/2 minus 1, or natural log of 3/2 minus 2. We throw it back into the original equation.
You're plugging in the negative into the log function.
Right. If I plug 1/2 back into this.
Oh, by plugging it out.
That's what's extraneous. That can happen. Yeah, wrong. Good.
Can you like put everything to the over E kind of like this?
Oh yeah, you can do that too. Yeah, you still get the same conclusion. You got wrong. Let's see. No, yeah, that could work.
I plugged it in it.
But you have to Oh no, you can't. No, you have to. No, not like that. Yeah, exactly. Yeah, yeah. You gotta raise a single log first, or erase all that junk, then combine it afterwards. Yeah. Yeah, Rehan. Yeah, good. Because it's a plus. It's a plus. That's why. Yeah, combine it first. Yeah. Only B can be cleared. All right, one more, guys. Let's look at E, and then we'll do logistic growth after that. You guys quiet, please. I'll do this with you guys. If you have log x plus 20 raised to the half, and I'll skip a step. I'll move the log x to the other side as well. The logs drop out. Half is a radical. Okay, so far, you guys with me? Power property, move the log x to the other side, drop the logs. Okay, what would be my next step? You guys square. Oh, look at you, Ollie.
Oh, yeah.
Wait, love the mental. Yeah, you did.
I got some. What if you use a negative to divide? To do like square x plus 20 over x equals 0.
Sure, yeah.
But then the x, like when you multiply, you get.
All right.
Well, no. What's going to happen? You have 10 to the 0 power, just 1 on the other side.
Oh,
That's what you didn't do, William.
that's what I forgot.
Yeah,
You're totally right.
I know I'm right.
Yeah.
Okay, let's keep going. You get 2 answers, but -4 is incorrect. It's extraneous.
Well, yeah.
It's extraneous, so that's no good. So that won't work for us. Okay. Okay, we're good?
Good.
Yeah, all right. So hopefully that's just a lot of review stuff we're doing. Now, let's talk about logistic growth models. This is actually a really good model. It's very accurate. So if you think about like when COVID was happening 4 or 5 years ago, ultimately there has to be a leveling off, or they call it the flattening of the curve, right? Like when they talk about the flattening of the curve, they're really talking about this. Because ultimately everyone just gets COVID and that's it, like reach herd immunity. Or if we're talking about influenza or flu at our school, like fine, people get sick. After a while, everyone gets sick, right? So things just can't go up forever. There has to be a limit. And that's what logistic growth models do. They show that limit. The equation generally looks like this. Y equals C over, and I tend to write it like this. Some people could also write like this as well.
Is the E like actually E?
Yeah, the number E. Yep, letter E. And K some constant. So there's a couple ways you could write it. C is what I call the limiting factor. Because ultimately when X gets really large, let's say X is time.
Let's say 1 plus e to the kx.
Correct.
How is 1 plus e to the kx the same as 1 plus?
It serves the same purpose. I mean, it would follow the same model. You can model it any way you want, really. You can model it either way. It will still have the same. The inputs and outputs still be the same. It's just another way of expressing it. So the E and the K, like, would be obviously different numbers than A and B here, but they would serve the same purpose. And it's kind of weird, but it does work that way. Hold on, Ollie. C is called the limiting factor because if X goes up forever, like COVID, right? We look at like, well, after like, no one wears masks, like say we're in Idaho or Alabama, I don't know, I won't get political. Or you're a red state, okay? Or you're Fresno, okay, around here. Yeah, people didn't wear masks, right? So everyone got sick, right? So what happens is that you reach a certain limit, right? As X increases, what's gonna happen here is that this gets really large, right? Actually, I take it back. B would actually be, actually, I believe B is gonna be a fraction. Yeah, if I'm not mistaken, I think B is gonna be between 0 and 1. So what happens is that this gets really small when X gets large. Ultimately, Y just equals C. Yeah, B will actually wind up being some number between 0 and 1. And I think K here is actually a negative number, if I'm not mistaken.
So it's the parent function as an. Horizontal asymptote of
Isn't this just like an inverted cubic?
Not quite, no.
Is this the hyperbolic tan?
Yeah.
So it's the same thing?
Actually, I should know what hyperbolic tan is. I don't.
I think it's also.
So you might be right.
Is the asymptote, is there an asymptote?
Yeah, there are two asymptotes. Yeah, by the way, 2 asymptotes. There'll be Y equals 0 and Y equals C. Yep.
It looks very similar.
No, they won't cross. They won't cross. These won't have vertical asymptotes because the way the denominator is set up, these won't have vertical asymptotes. The y-intercept is simple. It's C over 1 plus A times B to the 0 power. So it's C over 1 plus A. And also one thing I want to draw your attention to. You see how like this curve's getting pretty steep and it gets less steep. So that's what we call concavity. So like we call this first part concave up because we see the rate of change, like the rate of people getting COVID, getting faster and faster, like, oh, 10 people got COVID, oh no, 1,000 people got COVID, whatever. And then people die, and then that's what happens. I know I shouldn't say that, that's kind of, it's not, should joke about that, but yeah. But things, everyone gets infected, right? Or they die or whatever. So, but that's why it's called the flattening of the curve. Like, oh, we have to eventually, stop the spread of this disease, right? So anyway, that's what's going on there. Using analytical methods from calculus has shown that the maximum growth occurs at this point right here. And actually, I'm not sure. Oh, actually, it is. I'm not sure how to label that.
C over 2.
Yeah, but I'm just trying to think of how to label the X.
Well, yeah, you can't do the X, right?
Yeah,
Wait,
I'm-
is it 8 in those?
Well, yeah. Well, I don't know what the scale is. I mean, no idea. Yeah.
So is it always, the asymptote's always that way, because you're
Yes, no, it was a one.
even if.
Let me just call. Well, yeah, go ahead.
If there's a translation, the horizontal asymptote of y is zero control.
Yeah.
It's like-
I'm gonna call it this. Sorry. Go ahead. Sorry. There's like 2 questions. No, the y value I see over 2. I'm trying to think what the x value is, and that's why I'm not really sure.
Not just be 0.
I don't think it's the same thing. I don't think.
Sorry, I know.
I don't think it is. But it occurs when y equals c over 2. So we'll say halfway, if that makes sense. Yeah, so anyway, let's solve for x. Let's do it down below.
Minus the vertical displacement.
Sorry, say again?
Like what in this shifted up or like.
Well, yeah,
Well, that's if you ask them to the outside, we're not going to do that.
So what do all these variables represent?
Hold on.
So we got like K's.
isn't C the only one that like is a real thing? Everything else is just.
Yeah, so if I were to work this out, give me a sec here, guys. So the C's cancel on each side. You get this. If I cross multiply, I get this. If I subtract 1, I get this. So b to the x
Yeah,
equals
0.
1 over a. Well, that would just be a then.
X equals 0.
No, I don't think so.
It was one. Wait, why do you?
I think it would just be that. No, if x is 0, then you just get a. That wouldn't be true. Yeah, I should double check notes because that seems weird to me. We usually don't deal with problems like that. So that just seems weird. But we'll just move forward. Yeah, let's move forward. But you can see what I did. I set the equation equal to c over 2. I cancel out the c's. I cross multiplied, subtracted the 1, divide the a, and isolate x by using a log. So I know that's correct, but it just seems weird. Like I don't know why that's not a note. Yeah, I don't know why we're doing this. Anyway, let's move forward to example 4. This is what I do care about. Yeah, sure, go. Yeah.
So. I don't know, I guess maybe it's just like.
More conceptual.
Interesting. But like.
Mhm.
So that C value, like for this next problem is just gonna be 50.
Yes, correct. Right. Now, this is what I really do care about.
Really
Oh,
just
word
like
problem.
C over 1 plus. the number
Right.
exponents.
So you see how this one uses e in the equation, right? So that's one of the variations of this.
Why wouldn't this just be 50 E squared? Like, why would that look?
Oh, you can't do 50 divided by each other separately. That'd be this many order of operations.
And the exponent's always gonna be a negative because.
Yeah, here's
it
what's
has to
happening.
get smaller.
So when t gets large, right? What's e to a large negative number?
1 over.
That gets really small,
really
right?
Small now.
Yeah, so you see how when t gets large, that just goes away. And what was y approach?
50.
50, exactly. That's why that's a limiting factor, right? But let's determine the initial population first of this organism. Ethan, go ahead.
Never mind, I just thought of something.
Now, what do you think of?
The fact, like,
Okay.
the reason why it looks like that is because it never switches signs, right?
They do.
No, like it never gets the negative.
No, t. No, we make k the coefficient of t negative, so that when t gets large, ultimately this goes to the
Yeah,
limiting
like,
factor.
the y never becomes negative.
Oh no, though that's true, right? Because the bottom's positive and the top's positive.
Yeah.
Right. That's true. So you should get this 50 over 1 plus 9. 50 over 10. So we start with 5. Does that make sense?
Yep.
And the carrying capacity, which is the same thing as the limiting factor, is 50. And the turn time of the maximum growth of the population occurs. Well, yeah, because 25 equals this, right? So 1/2 equals that. Cross multiply. Okay, so obviously I know how to do that problem, but I guess the generalization was throwing me off a little bit. I didn't know this generalization for that. But anyhow,
So,
Why is it negative?
because there's a negative t. And plus natural log 1/9 is gonna be negative itself. So we have to, because you're not gonna have a negative time, right? Because natural log 1/9 is negative because the base e is higher than 1/9. So you have to raise e to the negative exponent to make it 1/9. Hence multiply by another negative to get back being positive. Plus it's part of the equation too.
so you said it equal to 25 because
Mhm.
the point where the maximum growth occurs
Is-
is half of C.
Correct, right.
Means if the exponent's negative, it always. will be a negative solution.
Correct, right. So it takes about 2.197 months. So why don't you guys try example 5? All right. Yeah, this is the model. And we'll check in about a couple minutes. You'll need a calculator to do part A.
I think we've had this exact same problem before, like last year.
Great.
Which one?
We'll need to get rid of that because we're repeating our efforts. We're actually trying to work on to not do that for next year. Yeah, because we noticed that this happened in a lot of our classes.
Oh, yeah. How do we know that we did this problem in Algebra
You
2?
did a good memory.
Oh, no, I know we've done this. I recognize the problem.
Which was example 4?
The 5, the college.
I do not remember that.
I don't think we've done this like exact one, but we've had like the 5,000 before.
I have a folder of like
I remember
everything.
5,000.
I bet I could find it. 100% of every paper I've ever had for the past couple of years. I have there's one folder. This is semester 1. This is semester 1 of sophomore year is much bigger.
54.01.
Like this.
Are you gonna have 0.1
It's
of the
actually
two?
exploding. It's literally.
I got that wrong.
Fours. Oh, that's the top one.
Oh,
All right, hopefully you got 54.019 people, or in fact, that's 5 days. So it's kind of slow at first, you know, like you can plug in like 1 day, I don't know, like not many people are infected. But it starts rising pretty fast. 40% is 2,000 people are infected. And this is probably a more accurate model. We actually work to like take a scatter plot and like plot the data, like, hey, let's just see how many people are getting sick over a 20-day period or whatever. And then you plot your data, will follow a nice curvature, and then you can fit it with just a function to this. There's actually for software that actually your graphic calculator can fit it for you too, if you have the data points. Angela, go ahead.
Wait,
Of course, yeah.
2.5 minus.
Yeah, so then that's just alpha at this point. I'm not getting here.
You
What
need
did
to
what did you do to this?
anything to
E
do
power weight 3 times 10 to the negative 4.
That's
Did you just divide 1.5 by
about 49.99.
Yeah. So that's
Maybe
equal to,
I don't know where we're
that
at.
one, like a computer, like a do over or whatever. I don't remember.
or natural loss minus natural loss.
Right, everyone.
Yes. Yeah, no, you're.
Yeah, sorry, that's
Why would
negative.
we
Because who likes to use bathroom?
Well, yeah, you can't do that, dude. Because 49.99 is not your base. Your base is E.
Oh,
Yeah.
It'll just be 4,999.
You gotta divide that first. Because that's, remember, when you're doing the log, you're undoing an exponential equation. 49.99 is not part of the exponential equation, it's the coefficient of it.
So I Googled this. This is tan H. I
Oh.
plugged in here. If you plug into -1 and 2, they look really similar. So I plugged in here. It says they're equal.
This is the hypervoloctan. Yeah, I just don't.
Hyperbolic
remember.
band.
Yeah, I'm just rusty with that stuff,
If
so.
they're not actually directly equal though, you have to have
Got
like
it.
very specific coefficients.
Okay, any questions here? All right, yeah, because you guys do want some food. So what I'll do is this, we can actually wrap this up on, no. No, we could wrap this up on Tuesday for sure. Because I think you guys get the idea of how to do this work problem. Why are you 2 days off? Oh, okay. All right, so let's head downstairs. You have to just hang out downstairs while